Chapter 2. This is the second of the two-part series of Tegrity recordings for Chapter 2, and this will focus in on unit conversion. So you should have already listened to Chapter 2a, which focused on significant figures. So first off, let's consider pizza. Most pizzas have 12 slices of pizza in them. So if I need 48 slices of pizza for a party, then it makes sense that I would say, hold on, let me get this going here. I have my 48 slices, and I know that there's this ratio of 12 slices to one pizza, which is the same as saying 12 slices over one pizza. Or I could say equally one pizza over 12 slices. So then if I'm starting with slices here, and I want to know how many pizzas I need to get that amount, then I can use one of these ratios that I made up here to figure that out. The question is, which one? So if I have 48 slices and I want to go to pizzas, then I want to cancel slices and create pizzas, which means that when I look at these two possibilities, we can walk through both of them. If I have 48 slices, I want to multiply by the one that will cancel slices. And to cancel slices, I need to divide by them. So over here, I have a ratio that has slices in the denominator, which means that if I put 12 slices down here to one pizza, when I multiply this out, it's the same as saying 48 slices, I'm just going to start abbreviating, times one pizza divided by 12 slices. So what happens to slices? Well, it cancels, right? Because slices divided by slices is 1, leaving me with the unit of pizzas, which is what I wanted. Now, you've probably been sitting there thinking for a while, well, duh, you need 4 pizzas. Great, we just showed how you would mathematically do that. I need 4 pizzas. Fantastic. Let's make it a little bit more difficult. The whole sort of big picture thing that we're doing here is called dimensional analysis, or unit conversions. Both types of ways of talking about this are used pretty generically. So we have this question: how many feet are in 45.7 yards? We know that 3 feet equals 1 yard, which means we know that we can write our ratio as 3 feet over, get my foot in there, 1 yard, or 1 yard over 3 feet. And which of those ratios I use is going to only be dependent on what unit I'm starting with and where I want to go. So the unit that I'm starting with is the unit that's attached to the number, 45.7 yards. And the unit I'm going to is the one that it asked me for, which is feet. So again, I want to cancel the unit that I'm starting with, which is yards. And I want to create feet. So when I pick which of these two ratios, here or here, that I'm going to use, which one makes sense? Well, hopefully you pick the one with yards in the bottom, because if I have 1 yard in the bottom to 3 feet, then we see that yards are here and here, and they divide themselves out. So when I go and do the math, I have 45.7 yards times 3 feet divided by 1 yard. What happens to yards? Well, they cancel. They go away. And I'm left with feet as my unit, which is what I wanted. So then I can put my math into my calculator, 45.7 times 3 which gives me 137.1. And now we have to stop and check our significant figures. Because, as we learned earlier in Chapter 2, the number of significant figures when we're doing multiplication and division is going to depend on the smallest number of significant figures used in the calculation. Well, there's an additional twist when we get to unit conversions, which is that when we're looking at sig figs, we only look at the measurement that was given. So in this case, the 45.7 yards has 3 sig figs. And that's what we're going to use to decide how many sig figs our answer should have. Now you might be sitting out there going, well, wait a minute, what about this? What about the 3 feet equals 1 yard? Well, that is a unit conversion. It equals 1, which means that it can have an infinite number of significant figures, because we get to it actually by counting. It's what's called an exact number, which means that it wasn't measured. This is actually a definition. 3 feet does equal 1 yard. That's the definition of 1 yard. It makes it an exact number which has no uncertainty. You run into exact numbers in other places too, like for instance when you're counting something. If you count the number of fingers on your hands, you will always come up with a total of 10. There's no uncertainty there in how many fingers you have. Versus measurements, for instance, the 45.7 yards, we know has uncertainty because it's a measurement. All measurements have uncertainty, and we can count how many significant figures there are. 1, 2, 3. Which means now, as I said, our answer should have 3 sig figs. Well, 137.1 right now has how many sig figs? It has 4. So I need to drop the last digit and turn this into 137. And I don't have to round this time because what I'm dropping is a 1. Don't forget to tack on your units and to box your answer. Let's make it a little bit more difficult. How many nanometers are contained in 360 millimeters? And you may be thinking, oh shoot, what's a nanometer? If you go back to the first day handouts, remember you had a blue sheet that was handed out and it had things to memorize on it. And one of the things that you needed to memorize was a certain collection of metric conversion units. And on that sheet, which you might want to pause here for a moment to get out if you don't have it handy, it will tell you that 10 to the 9th nanometers equals 1 meter, which is a conversion that you need to have memorized, as well as the other ones that are listed. It also tells you that 1,000 millimeters equals 1 meter. So in terms of my plan here, I'm starting with 360 millimeters, but I need to get to nanometers. So I'm going to start my problem with the number that I've been given that I want to change, which is 360 millimeters. And then I need to set up some ratios. I know that I want to cancel millimeters, and the only conversion I have that involves millimeters is 1,000 millimeters equals 1 meter. I know that because millimeters is up here, millimeters should also be down here, because I want to make sure that I'm canceling them out. So that means I'm going to say 1,000 millimeters in the denominator of my fraction, and I'm going to finish the ratio and put 1 meter on the top. At which point, what happens to my millimeters in terms of math? Well, they cancel out, which is what I wanted them to do. And now I'm looking at meters up here as my unit. But I'm not done, because the question didn't ask me for how many meters, it asked me for how many nanometers. So now I need to get out of meters and into nanometers, which I have a ratio right here that shows me. I want to cancel meters, so meters will go on the bottom, right? Meters up here on the top, so meters must also be here on the bottom. So 1 meter goes on the bottom, and then I finish my ratio with 10 to the 9th nanometers on the top. So my total math here, 360 millimeters times 1 meter times 10 to the 9th nanometers, all divided by 1,000 millimeters times 1 meter. So what cancels? Millimeters cancel out, and meters cancel out. And actually, those ones cancel as well, but we're not super concerned about that. When I put it into my calculator, I've got 360 times 10 to the 9th divided by 1,000, which is a big long number. I get 360. 1, 2, 3, 4, 5, 6. Let's just check. 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7. And my units that I'm left with, remember from my math, are nanometers. How many sig figs should my answer have? Well, I'm going to go back and look at the the measurement that I was given that had 360. Sig fig with a 3, sig fig with a 6. Is a 0 a sig fig? No, it's not, because there's no explicit decimal point. So that tells me 2 sig figs in my measurement. I should have 2 sig figs in my answer, which I do. So I'm going to box my answer because it's good to go. Notice here, I showed all the steps to my work. I showed this ratio here, and I showed this ratio here. There are shortcuts you can take, but on the in-class exam that you'll be taking in the 4th week, you'll want to practice showing your work, because if I can see the steps you're taking, I can go ahead and give you partial credit. Okay. So what happens if we need some other examples? We've got 35.6 centimeters, and we need to know how many feet there are. So 35.6 centimeters, and we want to go to feet. And it's a good idea at this point to have both your blue sheet in front of you if you haven't memorized those unit conversions, and your textbook, because in your textbook on page 36, there are some common unit conversions that you'll find that you're running into. You don't have to memorize the unit conversions on page 36. They would be ones that I would give to you if you needed them. You do have to memorize the ones that are on the blue sheet. So we see when we look at page 36 that our 35.6 centimeters, that there are, well actually we have a combination of the blue sheet here, 100 centimeters in 1 meter. And if I want to go to feet, well shoot, this isn't actually what I wanted to do. But we'll go through anyway. 1 meter is equal to 39.4 inches. And finally, that 12 inches equals 1 foot. So notice I've made sure that every unit I wanted to cancel, for instance the centimeters, had a matching unit down below. So this cancels, and my meters cancel, and my inches cancel, and I'm left with feet. And so we can put that into our calculator. 35.6 divided by 100 times 39.4 divided by 12 gives me, my calculator says 1.1688, lots of 8s. How many sig figs should my answer have? Well, I go back and I look at my measurement, which was 35.6, which had 3. So I need 1, 2, 3 sig figs. The next number is greater than 5, so that means I have to round up. So this will become 1.17 feet. Okay. How many milliliters are there in 67 gallons? I think I have, yes, I have a place to write. So 67.0 gallons. And I want to go to milliliters. So this is where I'm going to ask you to pause your recording and actually walk yourself through doing this conversion. And then we'll come back together when you're done doing that. You can restart the recording and I'll go through the answer. Again, I encourage you to actually pause and go through this process, because if you don't practice it and you don't really sort of self-test yourself along the way, it'll seem like, hey, this is pretty easy because Anne's doing it all the time. But the object isn't for me to be able to do it. It's for you to be able to do it. So go ahead and hit pause and answer this question. Okay, so when we look at page 36, we see that 1 quart equals 0.946 liters and 1 liter equals 0.265 gallons. So quarts aren't super useful, but the liters to gallons could be quite useful, because over here I've got milliliters, and we know that milliliters from your blue sheet, there are 1,000 milliliters equal to 1 liter. So that's the handy thing about the metric system to point out, is that milli could be 1,000 milligrams equals 1 gram, 1,000 millimeters equals 1 meter, and just like we did right here, 1,000 milliliters equals 1 liter. So you can take any of those conversions that are shown on the blue sheet and use them for grams and liters and meters all the same. So I've also got for my gallons that 0.265 gallons equals 1 liter. Okay, so I'm starting with 67.0 gallons, which means my first step is to get rid of the gallons. I've got a conversion here that relates gallons to liters. So since gallons is up here, I will put gallons down in the denominator so that my units will cancel. And I'm going to have to, once I commit to the 0.265 gallons, I have to commit to putting 1 liter in the top. Gallons at this point crosses out. My units are gone there. My next fraction is going to relate liters to milliliters because I want to get to milliliters. So I'm going to use this one here. Liters goes in the bottom because I want to cancel it, and I commit to the rest of the fraction here on the top with 1,000 milliliters. So liters goes away. And when I'm done, which you should already have been done, 67 divided by 0.265 times 1,000 gives me a pretty big number. I get 252,830, which is a lot of sig figs. But when I go back and look at 67.0, I see I only have 3 sig figs, which should be reflected in my answer. So 1, 2, 3. The next digit is greater than 5, so I'm going to round up. So 2, 5, 3. And then I have to fill in the rest of them with 0 so that I still have a number that's the same size. There we go. And tack on your unit at the end, box your answer so that we know what it is that you decided. Okay. We could also look at miles to micrometers. This is going to be slightly longer. So I've got 5.60 times 10 to the 9th micrometers, and I want to go to miles. So go ahead and hit pause on the recording and work out how many miles there are. So hopefully your first step was to get rid of micrometers, and using the conversions that you memorized from the blue sheet, or if you haven't memorized them, you will eventually, there is 10 to the 6th micrometers in 1 meter. And then, going to page 36 in our textbook, we see that there's 1 kilometer in 0.621 miles. Now, why would the kilometer be a good unit to go to? Well, hopefully what you're picking up on is kilometer and micrometer are both in the metric system. So I should be able to get to them. So I've got meters here, which means if I could get to kilometers, and there's 1,000 meters in 1 kilometer, then I'll be able to get to miles. So putting in my last fraction for miles, 0.621 miles equals 1 kilometer. So units to cancel, micrometers go away, meters go away, kilometers go away, and I'm left with miles, which is what I wanted. And when you put that into your calculator, 5.60 times 10 to the 9th divided by 10 to the 6th divided by 1,000 times 0.621 gives me 3.4776. Look back at your sig figs and see we have 3 sig figs. So this should become 1, 2, 3. Going to have to round up. 3.48 miles. Okay. How many decigrams are there in 0.00325 tons? Knowing that 1 ton equals 2,000 pounds. I'm just going to sneak ahead here and see how many more examples we have. Oh, just 2. Okay. So decigrams from tons. So I have 0.00325 tons. And we know that 1 ton equals 2,000 pounds. So again, putting my tons in the bottom so that they'll cancel out. And then, now I have to think. I've got to get from pounds to decigrams. So when we look on page 36 in your textbook, we see that 1 pound equals 454 grams. That looks good. That will get rid of my pounds and move me into the metric system. 454 grams. Again, pounds is in the denominator because it was up here in the numerator, and I want them to cancel out. From your blue sheet, you'll have picked up on the fact that 1 gram equals 10 decigrams. So, put it in your calculator, 0.00325 times 2,000 times 454 times 10 gives me 29,510. Get my numbers right. My units, tons have canceled, pounds have canceled, grams have canceled. I'm left with decigrams. So this is DG. But significant figures, I had 1, 2, 3 sig figs. So I have 1, 2, 3 sig figs, and everything else should be filled in with zeros for placeholders. So 29,500. Get those numbers right. Grams, box my answer. Okay, the next example I'm going to wait on because in the next file that I'm going to open, we're going to talk about cubic units as well. So you can practice this one after you've watched this whole thing. So I'm going to end this PowerPoint and start, and start the next one, which we're still in Chapter 2 here. We're just looking at expanding our understanding of unit conversions. So this is a good breaking point if you wanted to stop and sort of absorb unit conversions. The next part of this recording will be about dealing with complex unit conversions. And there's a couple of real-life examples you can look up online if you'd like. Commonly where we find this is in rates or speeds. We're taking a compound unit conversion involving more than 1 unit, and then we're converting them. So let's see, we should have an example. So a patient needs medication at a rate of 3 liters per day, but the IV pump only has units of milliliters per minute. And this is actually a relatively realistic thing. Nurses are expected, and a lot of you want to be nurses or dental hygienists, to be able to administer medication at a certain rate, which means you have to be able to sometimes do some conversions, which is why you might be taking this class. So what shedding should you have on the pump? And we're going to break this down into a couple of different steps. We've got 3 liters per day. Notice now we've got 2 types of units. I've got a volume unit in the liters and a time unit in the day. And I'm going to need to change it into milliliters per minute. So I want then essentially to look at how do I get from liters to milliliters, and how do I get from days to minutes. So, oops, forgot my 3 liters per day. So here's my 3 liters. Notice I'm writing it like this, where it's over days, rather than like this. Because what I find with this setup is that students get confused about where the days actually are, and they don't cancel them correctly. So I don't recommend doing it that way. Now remember, I want to go from liters to milliliters and days to minutes. And so what I can do is just think about it that way. Let's go from liters to milliliters. Well, we know that there's 1 liter and 1,000 milliliters. So my units for liters still cancel, and look, I have milliliters. But right now, my units are milliliters per day. What I really want is milliliters per minute. So now I'm going to change the days to minutes. In one day, we have 24 hours. Now notice now, because days was in the in the denominator, days to cancel it has to be up here on the top. So days cancels out. Now I'm in milliliters per hour. I want to go to minutes. So 1 hour is 60 minutes. So hours cancels out. And now I'm in milliliters over minutes, which is nice. So my math then is essentially the 3 times 1,000 divided by 24 divided by 60. Which, in my calculator, is going to be 3,000 divided by 24 divided by 60, which I get 2.083. Notice 3 liters per day, only 1 sig fig. So I should only have 1 sig fig out here, and it's 2 milliliters per minute, is what the IV pump should say. Your turn, now that we've done one together. The speed limit on Neptune is 32 nanometers per millisecond. This is totally made up. Don't quote me on that. How many miles per hour is this? So go ahead and push pause, complete the problem. So I have 32 nanometers over 1 millisecond. How can I get to miles per hour? Well, I'm going to attack this as 2 separate problems. I need to go from nanometers to miles and from milliseconds to hours. And it doesn't matter which one I do first, as long as I do both. So nanometers, there's 10 to the 9th nanometers in 1 meter. And we remember from page 36 that I have a relationship between kilometers and miles, so it would make sense to go from meters to kilometers. 1 kilometer, because we know that there is 0.621 miles in 1 kilometer. So at this point I can check my units. Nanometers have canceled, meters have canceled, kilometers have canceled, I have miles. But I also have milliseconds, which I need to get rid of. So that's the second part of the problem. Milliseconds, remember milli means 1,000, so I have 1,000 milliseconds in 1 second. I have 60 seconds in 1 minute, and 60 minutes in 1 hour. So check your units. Milliseconds is divided into milliseconds, which cancels. Seconds is divided into seconds, which cancels. And minutes is divided into minutes. And I'm left with hours in the denominator and miles in the numerator, which is what I wanted. So doing the math, 32 divided by 10 to the 9th divided by 1,000 times 0.621 times 1,000 times 60 gives me 7.2 times 10 to the negative 5th miles per hour. Notice I checked my sig figs here, saw there was 2, and so my answer has 2 sig figs. Density. This is also where we run into compound units, and it's also where we're going to run into cubic units, which we're going to talk about. So the definition of density is that it's the mass of a substance divided by the volume of that substance. And generally you've run across densities in grams per milliliter or grams per centimeter cubed. There are 3 types of density problems that you are likely to run into in sort of a general pattern. And they're all basically similar. In one case, you're given the volume and the density and asked to solve for the mass. In one case, you're given the mass and the density and asked to solve for the volume. And in the final, you're given mass and volume and asked for density. And so we'll do an example of a couple of these. So in example number 1, your mass and density are given, and it's asking for the missing volume. So let's read the question. If the mass of a substance is 45.0 grams, that's telling me mass equals 45.0 grams. It's not a bad idea to write out what you're assigning as you read the problem. Sometimes students get a little confused when they start to do the problem and then they have to go back and ferret out pieces of information. So it's nice to have it lined up ahead of time. The density of the substance is 3.790 grams per milliliter, and we want to know what the volume is, question mark, in liters. So handily, what's nice to know about density, and I think I have, we've just listed what we know, we've identified what we didn't know, and now we need to think about conversions. One thing that's helpful to recognize about density is that when it's written like this, it actually means this. It means that 3.790 grams equals 1 milliliter. And that is a unit conversion, which means we can write it as a fraction, one of two ways, depending on what we need. Okay, so I got to go back and pick up the problem because I forgot. So we have 45 grams, 3.790 is our density, and we want the volume. So it's a good idea to start with a simple unit. So notice here I have grams, and here I have grams per milliliter. So the simplest unit is grams. And to think about this problem as essentially changing grams to liters. So 45.0 grams. So essentially I have a mass and I want a volume. And the density here is going to relate those two for me. So if I think about it, 3.790 grams equals 1 milliliter. That's what density tells me. And when I set it up like that, my grams will cancel. Now, I'm not finished, but I am heading in the right direction because now I'm no longer in a mass unit, I'm in a volume unit. But I need to be in liters. So my last step is to take my milliliters and change to liters. So liters cancel, and look, there's liters. So in terms of math, it's 45 divided by 3.790 divided by 1,000. And I get 0.0, and I need 3 sig figs, 119 liters. And there's my answer with 3 significant figures. Okay, I'm going to pass back through all this stuff that we just did. There's our solution. So your turn. What is the mass in pounds of a substance that has a volume of 5.70 quarts and a density of 2.94 grams per milliliter? So go ahead and hit pause and do the problem. Okay, so let's list out what we know. I think I have a solution page. I have a blank page for it. Let's see if it'll fit here. I have a volume equal to 5.70 quarts. I have a density equal to 2.94 grams per milliliter. And I've been asked to find the mass in pounds. So I'm going to start with my simple unit, the quarts. I'm going to use density as a unit conversion to change from volume to mass, and then figure out what unit mass I need to be in. So 5.70 quarts is a volume unit. I need to get out of volume into mass. But notice my volume unit and density is not quarts, it's milliliters. So my first objective here is going to be to take quarts to milliliters. Because once I do that, I can go from milliliters to grams using the density, and then from grams to pounds. So quarts to milliliters, we look on our thing and see that 1 quart equals 0.946 liters. Okay, so now I'm in liters, but I need to be in milliliters. So 1 liter is 1,000 milliliters. So that took care of this part here. So my next step is right here to go from milliliters to grams using the density. And since milliliters is up here in the denominator, in the numerator, I want to put my 2.94 grams here and my 1 milliliter down here. so that these will cancel out. My liters have canceled and my quarts have canceled as well. And then my last step is to go from grams to pounds. And there's 454 grams in 1 pound. So grams cancel, and I'm left with pounds. So hopefully this is what you did. So 5.7 times 0.946 times 1,000 times 2.94 divided by 454, I get 34.9, which is 3 sig figs, which is what I need. 9 pounds. Box my answer. There was my solution page. We also are going to run into cubic units and conversions, and this is actually in your lab number 2, as well as sometimes crops up in density problems. So the thing to recall is that y cubed, right, just like x cubed or something, is just y times y times y. So inches cubed is just inches times inches times inches. So when we're talking about a cubic unit, remember, we're talking about a volume. Like volume is length times width times height. It's lengths that are cubed. So if I have 56 inches cubed and I need to go to millimeters cubed, I don't have any equations that allow me to convert from cubic to cubic. But I do know from page 36 that there are 2 point, whoops, I have to erase. 2 point, whoa, I erased a lot. Go here, get rid of that. 2.54 centimeters in 1 inch and 100 centimeters in 1 meter and 1,000 millimeters in 1 meter. Now, how did I know that those were the ones I needed? Well, because when I look at this, I see I'm in inches and I'm going to the metric system. So I need a conversion that converts from the English system, inches, to the metric system of meters, based meters. And we know from page 36 that 2.54 centimeters equals 1 inch. So then my objective is just to go from centimeters into millimeters, and that guides the rest of my process. But let's address this cubic thing. So I've got 56 inches cubed. I have these conversions, but none of them are cubic. But we're also remembering that inches cubed is the same as inches times inches times inches. So if I want to cancel inches cubed, then I have to cancel inches times inches times inches, which means the same as this. Doing this conversion 3 times. Right? Because when you look at here, look, 1, 2, 3 inches cancels inches cubed. What if I created on the top? Well, centimeters times centimeters times centimeters, which is centimeters cubed. So I could write it this way, or we could be a little bit more space conscious here. And when we go to meters, recognizing that 100 centimeters to 1 meter, that the same thing can be written as that conversion cubed, the whole thing cubed. And then my last one is going to be 1,000 millimeters per 1 meter, whole thing cubed. So when we put this into our calculator, it's essentially 56 times 2.54 cubed, or 2.54 times 2.54 times 2.54. If you want to do it that way, divided by 100 cubed, divided by, multiplied by 1,000 cubed. And so what we find is that this, I only need 2 sig figs, is 920,000 millimeters cubed. Because when I check my units, look, this centimeters and this centimeters and this centimeters were canceled by that centimeters, and the fact that it was cubed up here. And this millimeters is canceled by this, excuse me, meters is canceled by this meters. Both of them were cubed. Both of them are cubed as well. Okay, your turn. How many liters are contained in that number of cubic yards? Go ahead and hit pause. Okay, so I have 360,000 cubic yards, which I need to get to liters. Now, a really handy conversion to know here is that 1 centimeter cubed equals 1 milliliter. So that means my plan here is to get from yards cubed to centimeters cubed, because that will get me to milliliters. And if I get to milliliters, then I'm in the metric system, I can go to liters. So the question is, how do I get from cubic yards to cubic centimeters? Well, we know that there is 1 yard is 3 feet, which, if I cube, will work. And we also know that 12 feet is 1 inch cubed. And from page 36, it's a handy unit conversion to remember, 2.54 centimeters equals, oh shoot, hold on, I gotta erase. Here we go, get rid of this, because look, I was trying to put centimeters on the bottom, clearly where it did not go. Okay, 1 inch equals 2.54 centimeters cubed, which takes me to cubic centimeters. See, look, yards went away, feet went away, inches went away, I have centimeters cubed. Now, I have this handy conversion down here, which tells me 1 centimeter cubed equals 1 milliliter. Notice, I don't need to cube this. It's not a distance measurement anymore. Now I'm in a volume, so no cubing your volumes. And then last, 1,000 milliliters equals 1 liter. Pop it into your calculator, remembering to cube everything. I've got 36, 1, 2, 3, 4, times 3 cubed, divided by 12 cubed, times 2.54 cubed, divided by 1,000. Which ends up being 92 liters. 2 sig figs, because I had 2 sig figs here in my measurement. Homework problems are pretty much what's left of Chapter 2 from once you've completed your significant figure problems. So these are all conversion problems, from simple to complex to density conversion problems. And again, you want to practice these because you want to be able to do successfully on your quizzes and exams. And without practicing them, it will be kind of difficult to do that. So good luck, and I'll talk to you later.